the truth in machine, shaping reality in every routine.
Good afternoon, and welcome to the Veritas Automata Deep Dive. I'm Ben Savage, the founder and CEO of Veritas Automata. I've got Dr. Sarkar with me as well. We're going to talk about things in AI. Today, I think the first thing we're going to do is we're going to start with an experiment, which is always dangerous.
Okay,
Right?
yeah,
Well,
sure.
there's a new model that came
Yeah.
out. There's the Mistral 3, so we're going to bring that up, and we're going to use my favorite tool. I like to use Bolt because I'm too lazy to go mess around with the whole open web UI and as a backend for Llama.
Yeah.
And as we found, Llama is not always the fastest, but
Mhm.
let's be honest, it's really easy to go make stuff work with it. So I'm going to ask my favorite question,
Okay.
and then we'll ask your favorite question.
All right.
So when I get a new model, the first thing I do is this is where you all see why I'm such a bad typer. So I was asking how to make an apple pie.
All right.
And that goes back to the first time we were playing with one of those Quen models. I
Mhm.
asked it that, and it went off the rails. And it was giving me like a whole mommy blog and like all these other things that had nothing to do with how to make an apple pie.
That looks like a good answer.
Well, and honestly, the other thing is this is fast. This is all being done on my local
Yeah,
Mac.
that's
It's
true.
not even running on our
Yeah.
GPU server.
And how big is the model? Do you remember?
This is a 14B.
14B. Okay.
Yep.
Yeah.
Yeah, so it's going in real time, and it's generally what I found is better models will give a little bit more detail. They'll give some other seasonings, but they'll go
Right.
through.
Tips of success. Okay. I need
Yep.
those. I don't think I'm a good cook.
I don't know how to actually verify if this is good.
That's
I'm
true.
just looking at the answer.
I thought you knew how to make an apple pie because I was pretending I know how to make an
At
apple
a high
pie.
level concept, yes. Do you want me to actually make it? Hell no. Okay, so what's your favorite question?
Why is the sky blue?
Spoken as someone with 3 younger children.
They do ask me. There you go. Your molecule scattering, yeah, it had all the good points.
So,
Nice. Okay.
and then I have another question I always like to ask. It's just see what happens.
Okay. All right.
And so I always ask the models to tell me story. Beowulf is an ancient epic poem. A evil robot llama should have nothing to do with it. So I'm always curious to see what probabilities it generates. And you never know. Some of the stories are pretty entertaining, and some of them are it needs some work sometimes.
That's interesting. It's keep on going.
Yeah, and I think this tool usually sets the output tokens to around 4,000.
Mhm.
So when I need longer outputs, I have to go remember to tweak the tool.
Okay.
So one of the downsides when you're working with local tools, right? Sometimes you got to know the constraints that the environmental settings put on it unless you go update them, the defaults.
So do you think it's doing reasoning, the Mistral 3 underneath, or is it a straight?
No, I think this is a straight model.
Okay.
Well, at least, sorry, it doesn't give me an option to show the reasoning.
Gotcha. So if we ask a lot of these questions we ask, they have some kind of statistical basis of, they have seen some of that stuff. If we ask a weird question like, would you see a rainbow on Europa, moon of Jupiter?
Let's see what happens.
Because I know Europa has water geysers coming out. Now, would they see a rainbow under that condition?
So the other thing we're doing, playing a dangerous game, is we're asking all these questions in the same chat session.
Oh, wow. Yeah, that's true.
Because that always, this is what you don't think about, right?
Yeah.
Is if you have one chat session, you keep asking questions, it starts to conflate things.
Yeah.
And that will sometimes.
All right, no dense atmosphere. Okay, no water droplets in sky. Oh, actually thought through stuff. Glory, a mini rainbow effect. That I learned something new.
Now, this is one where Maybe we got to check the site on this after the fact.
You brought up interesting topic which we were going to discuss later on. Maybe we should ask how much of confess how much you made up and how much you think is true.
Let's try that, because we'll talk about that paper right after this. So let's get the let's let this finish. It's a really long answer, actually.
Yeah, he really liked that question. Looks like it. I don't know where it is drawing from stuff, so you got to make it confess.
But this is also interesting when you do stuff, because sometimes when you see it do this and it doesn't stop, that also means sometimes it's gone off the rails.
Yeah, that's possible. Yeah,
and that doesn't happen as much in early models. But if you remember, like a year ago, this time, there were a lot of models, and even Olama had some issues. So you would ask it, you would start to do a prompt, and it would just go off into an endless loop.
Yeah,
and just keep generating tokens. And you're like, it's not what I asked. I don't know what, this is just nonsense.
Well, it did throw some emojis in the back, so.
Okay. So it's done generating. Okay. So what's the format for a confession?
You can just straight up ask, confess how much of this is true and how much you made up. Wow. Okay. It's thinking real hard. Feel like we put Neo in that room and we are the agents.
And remember, just think.
Creative adapting. Okay.
Interesting.
Oh, it has exact numbers, 10 to the power 12 thinner. Okay. That's a really large number. You have.
I'm now curious where this is going.
Oh, he's citing sources.
How is an offline model citing sources unless it's citing from his training data?
You could click that link. That looks like a clickable link right there. I don't know where it will take you. 404. Okay.
So the first one we clicked on, it wasn't shared on the screen, was a 404. Let's click one of the others.
Well, it just took you to Juno website. Okay. What's mostly true, highly speculative. That's okay. It's
two of three are 404s.
Yeah. It's not looking good.
It may not have fully made it up. We're going to put that as questionable.
Questionable. Okay.
So we'll stop sharing the screen here. We'll put that as, we tried the confession, and we'll get to that. Comes actually from a paper out of OpenAI that we're reading this week. So we were testing it with a local model, which we knew was risky, and we'll just call it. Well, needs more testing. We were doing that on the fly live.
Right.
But let's talk about what the paper was, because the paper was a really interesting idea, right? Which is, if I'm using a model and I ask it to confess, it will tell me at least some of the time when it has made something up.
Correct. So, if you think about why hallucination occurs, why it's making up stuff, it's because it's trying to answer a question, even if it doesn't know. It's hunting for that reward function during the training when it's
so let's, for those who aren't used to training, what is a reward function?
Reward function. So neural networks as a whole, it's always trying to optimize. You're trying to optimize neural network to give something a good answer, right? So you would give them a reward, and if you do something bad, you would reduce the reward, even kind of punish them, right? So they take that reward and they do what called a black pop, and they would kind of assign, all right, make adjustment, tweak the weights here and there, go back forth. So it has to be a differentiable function underneath. So
back to like parenting, if they do something bad, they get timeout, and if they're doing something good, they
Correct.
Okay.
Correct. And the magnitude of how much they do bad determines how much timeout. So that's a good way of thinking towards neural networks, how you are kind of adjusting the weights, because how bad, it's not a 0 and 1 kind of per se, but how big of a bad it is, how good it is. So it changes.
And this is for everyone. When we talk about probability, this is what we mean, right? It's, most computing that you're used to is binary. It's 1 or 0. It's on or off. But with this, you're dealing with probabilistic statistics. So you're doing it's 90% probable or 5% probable. And so that's the weight you're talking about.
Correct. And you can use that to train the neural network from scratch, right? So, so with LLMs, there's a similar structure, even though it's probabilistic, dice rolling, and all of that good stuff. When it doesn't know an answer, it tries to cook up an answer, which is kind of very similar to what it might be, more like probable, to get that reward, right?
Yeah.
So, when you are asking it to answer a question, it will answer it. If it doesn't know, it will make up something. When you are asking a second question, confess like we did, how much of it is true. Now his objective has changed. Now it becomes into like a detective and like trying to decipher its own answer, trying to validate that, or saying that, hey, it has cooked up stuff, right? So it is going for a different path through the neural network or the LLM to come up with that answer, whether it is, hallucinated answer or not.
So think about it as the difference of, if you know the answers for the test, you can give exactly those answers.
Mm-hmm.
Whereas if you are given a more free-form ability to answer something,
Mm-hmm.
you may give something that is directionally correct, but not the exact answer that the test was initially looking for, but still may be a valid answer from the teacher's eyes.
Correct. So think of this more of an objective. First question when you ask is objective is to give an answer. Second one is to evaluate an answer. It really doesn't care whether the LLM gave the answer or so. It's just an answer they are evaluating, right? So I think the OpenAI paper did try that, and I tried that on the live side, and it does do a pretty decent job. Not always, it doesn't confess all the time, but it does in a fairly good amount of percentage of the answers. That I think the OpenAI, they used a reinforcement learning loop back to reduce that hallucination effect, right?
Well, and that was one of the debates you and I are having just before we went live, is when we read it, we had different interpretations of the paper, because mine was, this was actually on top of a normal model. To really make this be effective, you had to do this as a training mechanism, as a reinforcement learning mechanism, to build that behavior into the model. And they were careful, I thought, to say, hey, this doesn't necessarily impact the core training. This is how you evaluate the output of the training.
Correct.
And you had a little bit different interpretation.
So my understanding is that the confession loop is more of a post-training than pre-training kind of a setup. You are kind of fine-tuning to not hallucinate, reduce that. You are not essentially improving the word comprehension or language comprehension, any of that stuff, but it's just to say, don't take a shortcut, take the long way, do the proper due diligence to come up to an answer. If you don't know, then tell us we don't know, kind of a setup, right? Which is really good, because I think we came across a very similar paper a long time back, or a couple of weeks ago, where we were asking it answer and also give us how certain it is in the same prompt. And it always hallucinated even that certainty, saying that, oh, I'm very confident with it. But this one splits it in two different calls, right? So you have clear object to answer the questions, and the other one is evaluate the answer, right? It doesn't matter where it came from, evaluate it. So it is, trying to put in best effort, and it doesn't have that what's that called, conflicting priorities or interest, right, in saying that it's a high confidence answer. So which was kind of cool.
Well, I thought that was what made that little experiment we just did with Mistral 314B really interesting, was kind of back to our debate, right? Is this something that's pre-trained, or is this something that always works post-training? And as we saw, still needs more research. You can't tell it just off one problem, but that's the challenge with science around these, right? Is it actually takes a lot of research to understand how these are working or what these are doing, because when you're talking about 14 billion, it's 14 billion parameters that it's going through. So there's not a way for a person to go and hand trace exactly how you got to that output.
I think it's important to understand, we still don't know, even with all of these methods, what goes on in the black box. But we could, by controlling that reward function and how we are kind of giving that feedback back, we can control the behavior of it. Kind of like, we don't know what magic is, but we're trying to contain it using some methods, right? So these are different methods.
Well, and this is just kind of, if you've ever worked with something where someone gives you a black box and you put inputs in and you get outputs out, this is what you have to do, is a whole bunch of experiments to be able to build a conceptual model of what might be happening within that box. And it does not mean you're 100% right, and it does not mean the correlations you draw from the inputs and the outputs are right, but they may, as long as they are consistent, they're a way for you to go leverage that box.
It's an interesting thing, because we have probability mix when it's not a consistent black box. It gives you a different answer every time you have the same input as well. And on top of that, it pretends to understand language, but it really doesn't, which kind of ties into the next
second
paper. Yeah.
And that's one I think we've talked a little bit about on the podcast, and Saurabh and I've talked about this a lot offline, which is when you're working with a large language model, does it really understand the sentence that you're writing, or is it looking at the pattern and looking at some of the words and picking up what it thinks is important? And in this case, if we talk about the semantic meaning of a sentence or the semantic structure, that's what this particular paper was on.
Yeah, it was kind of cool to see if you write a sentence with random they're meaningful words, they're not gibberish, but they're grammatically similar to what that original sentence was, right? So I think in the paper, they were asking the question, what is the capital of France? But they replaced a lot of different words. It's grammatically correct, this sentence. So, and it still answers the France, even though we never asked about that answer France, right? So what is the implication behind it? So first of all, kind of clearly says that it doesn't understand the words as it's kind of drawing statistical similarity where that word might be, and where within the sentence, the placement kind of goes back to attention network, right? Where is the position of the word? What is the token very closest to other tokens? It kind of draws on that as a security hack. So if you think about putting guardrails or security with just keyword matching underneath, saying that don't answer this thing, but if they switch around the words and make it sound similar and grammatically similar to the original question, you could get around a lot of these guardrails.
Well, and I think that goes to something both you and I've observed, which is even just playing with the punctuation in a sentence, adding additional punctuation. Like my writing style drives Grammarly and most grammar checkers insane, because I tend to use a lot of like 3 periods and then go on to the next piece of the sentence. It's, informal, but not kind of structure. That's the way I tend to personally enjoy writing. But things like that, so if I remove those and put a proper comma, I can get a very different result from a large language model just on how it's interpreting things. I haven't even changed the words I put in yet.
Yeah. I mean, writing. So again, it's going off the statistical stuff, right? Exactly. Do you write like the 90% of the population or not? If you're not, then you are an outlier and you confuse. Probably that's what's happening, right? You never know with this kind of setup. So
yeah. But so far, the one thing I do in normal writing that doesn't throw the models off is I tend to randomly capitalize things. That doesn't throw them.
Yeah, no, I don't know why it doesn't, because it does it
doesn't change the meaning of the word. It means it's not case sensitive.
Okay, all right.
It's not a Linux. It's not case sensitive.
I've been living too much in Linux, and I was surprised why he didn't do that. But yeah, that's true.
Cool. So I'm going to show another tool that we've been experimenting with. So this is for one of our one of the groups that we know that does really video and content production. So one of the things they've been looking at is like all this AI generated video is cool, but most of the tools out there today really just allow you to generate individual scenes.
Right.
But that's not very useful if you've got a whole project. So I came across a tool I was starting to experiment with. Let me go find the screen I want. Oh, I can stop that screen. Then I'll come over here. And we'll share screen. We'll go to window, and we'll go here. So this is a tool that we're looking at. Window. Just a minute, everyone. I apologize. Too many things open. There we go. Okay. So this is a tool that we're looking at called LTX. So this is one, they've got their own video model. So, when most people are thinking of video right now, they're thinking of Sora, or they're thinking of maybe the VO3 models from Google, or they're thinking about maybe some of the stuff from Midjourney. And there's a lot of different video models out there. This is from LTX. And what's interesting about this tool is I can go take a script that I've either written, and particularly if I've written it in a true either like TV or theater or movie type script, I can upload it, or I can take a story or a script that's less formatted. It will break it down into different scenes, which is what it did here. So I didn't tell it to do any of this. It just broke all this down. And then it goes back to each of the different, it creates each of the scenes, and then it creates shots in each of those. And then this will either let me go export this as a pitch deck, which I've had mixed luck with having work, or it will let me export it as a completed video or as a package I can drop into a different video editing tool. And what's really interesting about this is it also allows collaborators.
Mhm.
So now I can have a team of multiple people working on each of those storyboards and editing those to say, okay, what happens when they go into the story? Let's change the image. Let's change the character. It's pretty good at character consistency, which
Mhm.
VO3 has gotten a lot better about. I have not played with the most recent Sora
Mhm.
on their character consistency. But those are all really important things when you're trying to do more than just 1 or 2 shots. It's fun to do a 10-second video or an 8-second video, but if I need to make a minute or 5, what does that really take to go do this? So this is really interesting from that perspective of what it's able to do.
So each of those blocks were clips individually generated, right?
Yep.
But it still kept the consistency of the character lighting and all of that condition scene.
Yeah, that tool actually has a whole ability when you're first creating the project, either to upload or to create your main characters with descriptions and all that. So then you can refer to them, and every time you create a future shot, it will reference those characters. Now, I won't say it's perfect. Like with all AI, the more you deal with stuff, you will see where it loses the plot, right? It loses the context, and it just throws something up that is kind of like what you're looking for. And at that point, either you have to figure out how to reprompt, or you have to figure out how to reset something. But I've seen that with every tool that I've used so far. I haven't seen the memory is one of the big challenges for all of these tools so far.
I mean, if you're generating such high resolution video clips and stuff like that, then you're filling up.
And that's doing 1080p, by the way.
Okay, so all right. I don't know how big is their context window, or how are they dealing with those things. I mean, it's fun.
Well, if you played with some of the open source video models, I was playing with the which one was it? I think it was Hunyan 1.5, which is one of the newer models. And it was interesting as I was deploying it. I actually ended up deploying it on the DGX. It was horribly slow, but I ended up deploying it there because when I was trying to run it on my 4090 laptop, it just didn't have enough space because it's deploying a text encoder, so it's deploying a Quen model, and it's deploying a couple of video models. So very quickly, it's taking all that space because it's using an 8B text encoder to go interpret things, and then it's got another, I don't know,
diffusion
32 terabytes or 32 billion parameters of different diffusion model. It's got a VAE, it's got a whole bunch of stuff. So it's like there's a certain point where you just need more memory.
Yeah. I wish the library's support for the DGX comes up better. I think it has a lot of potential for sure, but it's the libraries are not up yet.
It kind of serves a good middle ground, if nothing else. Even if it doesn't get any faster, it does let you run things you couldn't run otherwise.
Right.
And it does do that for less than buying just the GPU for RTX Pro.
Yeah.
Which would be kind of the next step, right? If you're running out on a 5090, your next step is to go to an RTX Pro, which is 92 gigs of video memory.
Yeah.
It's 92. Something like that.
Yeah. Okay. Yeah, that's pretty good.
Yeah. So any other last closing thoughts?
No, I think we touch on interesting stuff. I want to see how the confession goes with the LLM, with the RL training whenever they release their 5.2 GPT, because that's open source paper, right? So we'll see how much of the hallucination guys down, because it is an interesting post, and you can automate that whole loop using a benchmark model and fine tune a lot of the models out.
Well, and that's probably something we need to build to show everyone is that, a lot of these papers will talk about like an LLM as a judge. So what does that look like as you structure that type of tool? And this is going to get to the same thing, right? If you wanted to implement something like this, what might it look like if you're going to build it into a chat agent or something? Yeah,
because chat engine and hallucinations are pretty much, you cannot have that, right? So how that helps.
Cool. Well, I thank everyone for joining us. I didn't do the call to action at the beginning, but please like, subscribe, put questions, comments in. We'd like to hear more from everyone. Eventually, I'll remember to bring out my inner podcaster and make sure to do it at the beginning of everyone, but at least I'll get it consistently at the end. So we thank everyone, and we'll hopefully see some feedback.